Okay, cool. So maybe try going out and then going back in. Um, okay. Would you guys rather go over just like the link or just go over like certain questions from the quizzes and stuff or both? We can do both. That's cool. Um, cool. So yeah. Okay. Everyone knows what binaries are, right? Obviously, I hope. Um, so like binary numbers.
Could you elaborate?
It's hard, a little pretty difficult. There's
I'm kidding.
like
You
a
don't have to.
number. There's a number, right? It's gonna be X or Y. No zeros or ones here. We don't talk about it. But yeah. So binaries, bits, bytes, knowing like the difference and stuff, right? So I don't even know if I know the difference. What a byte? A byte is 8 bits, and nibble is 4, I think. Um, I think. Unsigned integers are always positive. Sign whatever. If it's unsigned binary or unsigned integer, it's always positive. If it's assigned or binary or just a number in general. Um, that means it could be positive or negative. Um, we use two's complement. You just flip the bits that are given and add 1. Um, I don't know why the fuck she started talking about octal because I don't think we ever talked about that. But hey, that's just to the 8 or 8 to some power. But I mean, obviously, we're probably just going to be talking about hex. That's probably like the more common thing. If anything, it'll probably just be like switching between hex and binary, like the first quiz. So again, two's complement, which I think I spelled whatever. Um, Conversion from different ones. Is everyone good on like that sort of stuff right now? And we'll like IE is a little bit further down, but is everyone good with at least that sort of stuff? Um, 1 second. Cool. So yeah, everyone's good with that. We can just keep going, I guess. Um, I don't get subtracting two's complement if one's negative, one's positive. So isn't that just like you're just talking like addition if one's a positive number, one's a negative number? Or are you talking? Okay, so like, what do you mean? Like if you're subtracting a negative from a positive? Yeah, that makes sense to me. Yeah, like number 2 on quiz 1. Okay, let's look. Um, exponent for a. All right, Hollow, we'll get there in a second. Let's talk about the subtraction real quick. Um, yeah, so if you have if you're doing two's complement, you're literally just flipping and then adding 1 and then adding the 2 numbers. Yeah, we're gonna go over the quizzes later, probably at the end, just because I don't really know where they kind of stop, but mostly the assembly from the quizzes. But if there's any specific questions that relates to any of these, then yeah. Can we check the floating point stuff real quick? Yeah, okay, well, we can talk about that real quick. I think that's right before IE. So, for floating points, that's what you mean, like the stuff, like right, like oh shit, like this stuff, right? Right here, this arrow part, I think. Um, so when you get a number, right? So let's just say it's 25, or someone type like a decimal number, or like give me like a small decimal number. It could be like 1.754, whatever, 6.9. All right, hollow, fuck. Um, so with 6.9, right, you have to separate the two. So we're gonna say 6 turns into 0, 1, 1, pretty much, right? And then 9, right, it's 0.9. So we just take 0.9, and what you do is you just start going like this. You multiply by 2, right? And then you get a value. This is 1.8. Okay, because it's a 1, we take that 1 and we put it there. And now we have 0.8, right? We times it by 2, that equals 1.6. There's another 1 there, so we get that. Now we have 0.6 times 2. That's 1.2, right? Once again, a 1. And now I have 0.2 times 2. Well, this is only 0.4, which means we're not going to put a 1 here. And then you get 0.4. And you just kind of keep going. Instead, it's a 0. Sorry. Sure. That 0. And then again, times 4 times 2. 0.4 times 2 is 0.8, so that's another 0. And then it just keeps repeating that pattern. Does that make sense? So that's what. So it's like, okay, cool. Yeah, they'll tell us when to stop, usually about 8 bits. So like the for the quiz question, I think it was 8 and 8. So like you have to add another bunch of zeros over here, um, unless it's a sign extension. So just kind of, which this wouldn't be a sign extension because it's a positive number. Um, and so you just kind of keep going with that. I'm sure you did. Um, cool. Um, okay, cool. So continuing, we can just talk about, let's see, the IE standard, right? So all it is a 32-bit number, right? And it's just separated in different like portions. Excuse me. The first portion is a sign bit, right? This part. The second portion is the biased exponent, which is another 8 bits. And then the last part is the rest of it, the fraction part. You guys don't see my screen? Um, is it on? Are you guys on the app? Yeah, go to the link. Oh, I didn't pin it. My bad. I'll pin it real quick. Mobby. Is it frozen? Can you guys see it move or no? Okay, cool. There's hollow. Miguel, this isn't a quiz question. Sorry to like ignore this section. This is on this part for now. Cool. Okay, cool. So we're just talking about the IE standard right now. I don't know. Is Paprika, are you recording it? Okay, cool. It is being recorded. So 127, right? So okay, so we're only talking about I'm sorry, 32-bit numbers. If it's 64, it's doubled, I want to say. But we're only talking about 32-bit numbers, so we only need to know 127. So what it ends up being is it's 127 plus whatever the offset is, right? So in this case over here, like over here, the offset is this 7. So we say 127 plus 7. But the 127, it's neither like you take the 127 first, and then you add or subtract whatever your offset is from there. So Hollow, this is an unsigned number, so it's not going to be TM. You just have to know it's a bias. The 127 is just something you have to know. There's not really a way to do it. No, so it's 127 and then plus whatever the offset is. So if the offset is like -2, then you would subtract 2. But usually it's going to be a positive number. In which case it's like the 127 plus 4 plus 7, whatever. Came up with a cool trick to confuse the poor children. The poor children, all of us. But yeah, so if it was okay, it's 8 bits, Darlene. Hold on. I need a little bit. I need a calculator to do that. I'm not doing that. Binary to decimal. If it's 130, if it's 133, then that's the answer. Yeah, that's not 100. Okay. 127 is, yeah, that's what 127 is, hollow. And so then whatever you would just go backwards, right? So if it was okay, let me just do a problem. It's cool. Let's do, I don't know. What's a number? 5. Okay, well, I mean decimal. Give me like a decimal too. The quiz problem. That's probably a good one. All right, let's do the quiz problem. Cool. This is IE standard, yeah. Cool. So it's negative 9.6875, right? And so we can do the 9 portion, which is just going to be 1, 8, and then and so we have the 1 and 8, which is 9, and then we say, okay, now we need to do 6.875, so we can do 0.6875, and they gave us a chart last time. I'm like 99% sure, right? Does anyone else remember a chart, or am I just hallucinating for quiz 1? There was a chart. Yeah. Yeah, okay, thank you. So at the bottom of the quiz, there was a chart. Make sure you look for the chart. Makes life super, super easy because it tells you. But yeah, so we take that if you had to do it the hard way, because then it told you like where they should be, where the ones and zeros should be, and you could just solve it like that. But if you have to do it this way, you multiply by 2, right, and you get 1 point. Oh god, this is gonna suck. I'm just gonna use a calculator because I'm lazy. 1.375, right? And then you get 0.375 times 2, and this is a 1 now. And then that's going to be 0.750, which is a 0, and then 0.750 times 2, which is equal to 1.5, right? And so then you take the 1, and then it's 0.5 times 2 equals 1.0. And because it's 0, you can stop there. Does that make sense? Is it 1011? Yeah, sorry. Thank you. I did it right, but I put the wrong number. Cool. Okay. So yeah, there's your answer, right? So this is where we're at right now. This is what that is. And then from there, we just know, okay, well, we have to move it over into scientific notation, right? And so we change it. And so we say, okay, now this is equal to 1.00111011 times 2 to the third, right? As we moved over 1,
That's
2, 3.
positive. You still have to convert it to negative.
You don't have to convert it to negative here. You don't do it here. So in IEEE, IEEE, we do it at the end because the first bit, right, is a sign here.
True.
And so you just put the 1 there and that converts it. But you don't use the negative, so you wouldn't flip it here. So in this case, yeah, you don't flip it, and you don't flip it at all for IEEE. So like in the first quiz, I missed points on that because I did the same thing. I flipped it, but you don't flip it. You just use what you're given. So pretty much what we do here is for the sign bit, because it is negative, we put that 1 at the beginning. And now we have to solve for our exponent. So we say 127 plus 3, which is 130, right? And so we know 130 is just a 1 at 128, bunch of zeros, and then a 1 for 2, and then a 0 after that. IEEE is not Deuce complement now. So this is the convention. Flip, next convention, no flip. Fifth convention, you need to sort of know. I mean, yeah. This is part B, Miguel. So okay, so from here you have your biased exponent, right? So this is 130. This is saying it's negative. This is 130. And then we have to just fill it in. So we just take the rest of all this stuff and we just put that over there. So it ends up being 0, 0, 1, 1, 0, 1, 1, and then a bunch of zeros. Does that make sense to everyone? Cool. Who asked about the question? I feel like a bunch of people did. Is Jared, are you good with that too, or Hollow? What's that? Yeah. So this is our exponent, right? Right here, this 3. When we multiply, or when we turned it into scientific notation, are you there? Hollow? Okay, cool. So from there, we just do 127 plus 3, which is 130. And from there, we just have to calculate it in binary. And so in binary, we just like you know that 128 is a perfect, like it's a multiple of 2, right? So you know that 128 in and then it's 128 plus 2 is 130. So I can say, okay, well, I know I need a bit from 128. Then you have 64, 32, 16, 8, 4, 2, which I need another one because 128 plus 2 is 130. And then you say, okay, and then I need one more to fill in there, could be a 0. Where did the 3 come from? I thought it was a 9. So, Jared, we solved for the number, right? Like our binary number is this. Um, does that make sense, Jared? While I'm waiting, Darlene, yeah, the mantis is 23 bits. Okay, cool. So this is our thing. And so we just shift it over 3 bits or to the left. Does that make sense? And then that's how we get our 3. And so that turns into this right here. Yes, Miguel. Cool. Cool, cool, cool. Yeah, just remember that it's 127 plus something else. And so when I do conversions and stuff, I just think, okay, well, if it's greater than 128, the first number, or if it's 128 or greater, that first number here, this first binary bit, um, is going to be 1. And then you just need to fill in the other ones that will equal to whatever number you're trying to get to. That's how I do it. Cool. So are we all good on the IEEE standard? Yeah, just think it's not a negative, and then just realize that you need to put that negative at the beginning. Or at the end, sorry. Cool. Cool. All right. So I think that's everything for that stuff. Yeah, no shift operation. So if you shift to the left, you're getting a multiplication problem, right? Or you're multiplying by 2, and if you shift to the right, you divide. It's kind of self-explanatory, right? If you have a number that's like, let's just say it's 1, 0, right, which is equal to 4 or 2, then if you shift it over to that, it's just 1. Um, Sling, it would be if it was just a decimal number. So like if you gave me the number, let me just erase some of this stuff. Okay, if you yeah point zero, okay, that's a stupid number. I don't like you. All right, 0.0625. If we took that number and then we just solved for it, right? And then you multiply by 2. Fuck, someone want to do it for me real quick? I'll do it quick. 0.0625 times 2. 0.125. Okay, equals 0.125, and 0.125 times 2 equals 0.250, and then 0.250 times 2. And then I'm sorry, like I'm not filling them in, but it would be like this is the first 0, then the second 0. And so you just keep going, right? So here 0.5, and 0.5 times 2 equals 1. So it would be 0.0001. That makes sense? And then from there, because we know it's like this is what it would look like, because that's the decimal number, we just have to move it over 1, 2, 3, 4. And so we get 1.0 times 2 to the negative fourth. And so in that case, you do 127 times or plus, sorry, negative 4. And then you get 123, and then you do a bunch of answers. get it. Yeah, cool. Cool, cool, cool. It's always 127. Yeah, because it's a 32-bit number. It's 127. Keeps asking me out your call. Yeah, it's because um hold on, turn that off. Okay, hopefully that turns it off. Because I don't do the audio through the the stupid app. I do it through Discord. Yeah, you just have to remember the 127. If it helps, I mean, the reason why it's 127, right, is because it's a 32-bit number. So think of it like this: if it's 32-bit number, we know the exponent has to be only 8 bits, right? And so the largest number you can the largest number you can have as an 8-bit number, if you gave them all ones, is 255, right? But at that point, then you couldn't expand any larger, because if you wanted to go larger, you would need to add another bit. So what they do is they say, okay, 127 is the largest you can go with 7 bits. Now we have an eighth bit, so we can use that to make a larger number. Does that kind of make sense? As we patiently await Hollow's reply. Okay. Sure. I don't know what the fuck happened there, but okay. Yeah. What? I don't feel like that equals 127. Yeah. Unless you're talking about like negative. I'm like a little confused on what happened. 127 plus a bunch of zeros. Hollow, none of this is unsigned. Or none of this is signed. This is all like unsigned. So you're not gonna have like a two's complement number there. But we don't have to know that. Just do the addition. Just do this. Just do the addition in decimal and then convert it to binary. That's all you have to do. When you start adding with binary bits and everything like that, it starts getting confusing. I think we were talking about it last night because it was like if you have to add a negative number, then you can start getting all confused and stuff. Just do it in decimal and then switch it to binary. Just memorize the 127. Yeah, exactly. And again, I mean, if you want like an explanation for it, the explanation is that again, like you only have 8 bits. So in those 8 bits, right, we say if we have 0 and then 7 ones, that's 127. And that gives us this 0 bit to make one and have a lot of room. We have another, what, like 427 like numbers to mess around with at that point. Because if we make them all ones, this is equal to 127, and if we make them all ones, it equals 255, right? And so you have like another, like I said, like another 127. Yeah. So I would just do that. Just memorize the 127. It makes it really, really easy to do. What's up, Joda? We're going over IEEE right now. Um, yeah, mantis is the number after the decimal point. Correct. And then you have to make it into 23 bits, so you just add a bunch of zeros. Exponent default 127, exponent bits. Sasquatch, literally just I promise you, if you think of it as a decimal, it makes your life a lot. Oh, okay. Well, yeah. If you add, yeah. What? Okay, that makes sense. Too. I was like really confused what you were saying, but that makes sense. If you just think of it as a decimal number though, and you just add the two decimal numbers together, your life's going to be a lot easier. Because then, if you start thinking of it, just remember 127. I'm telling you, makes life easy. Okay, cool. You guys want to go from for the 0.0001 where we moved it, became 1 point times sign should be the sign would still be 0 in that case then because it's still a positive number. Cool, no problem. And then yeah, the exponent would be 123, and then you just solve for all that stuff. Cool. I'm gonna wait until do number 2, x minus y then. Sasquatch, you add so you take 127, that's what you start with, and then you add 3 to it because our exponent is 3. So you're taking the 127, you're adding 3, it becomes 130. You're not taking the you're not going to 3, you're just adding 3 on top of what 127 is. Yes, correct. For converting, if it's negative, you will do 2's complement. Yeah. We're gonna go over all the notes, Miguel. We're just talking about a specific question right now. Cool. Also, Cara, your messages last night about Alfaro, was it? I'm telling you, I was reading that shit this morning. I was just dying. It was a great like wake up before my fucking 43 text. That was funny. You must not be me. It was about Herman's. I don't remember, dude. Honestly, I didn't have either of them, so I got out unscathed because they're both terrible. I mean, I can repost it, but what was that called? The what was it? The pussy muncher, I think it was. Yeah. Oh, mechanic. My bad. Yeah. She's available for 40. Yeah, anyone who's taking 45J, I'm sorry. Um, yeah, have fun with that. Apparently, it's not a hard class though. Rooting for go. Wow, there. Wow, someone found it. Weird. Car, are you taking 45J by any chance? Does Hermans need to watch out? I feel like Hermans has been teaching here for like I have no idea, like 4 or 5 years. Since are you talking about our final or oh really? It was only two quarters ago. Shit, this final's worth 35% of our grade. Yeah. Okay, let's get back to this real quick. Sorry, I distraction. Um, okay, so logic design. Let's go into that. Yeah, cool. Truth tables. Does everyone get truth tables? You take the. Oh, I wanted to do adding or subbing. You want to do okay, like a two's complement problem. Okay, let's do number two. Um, okay. Um, I don't even know if I'm gonna do this right, but let's see. Um, you have one, oh shit. 1 0 0 1 1 0 0 1, and then you have to flip it and add it, I'm assuming. Yeah, cool. 1 0 1 1 1 0 0. So it's 1 1 0 1 1 0 1 1 1 0 1, and you add them together. So this is a zero, this is a zero, this is a one, this is a zero, this is a one, it's a zero, and that's a one, and a zero and a one, right? And so is that right? 0 1 0 1 0 1 0 0. So then this becomes your answer right here, right? And then it's an overflow, um, because you're adding two negative numbers together, and then you just turn this into a decimal number, and um, yeah. Is there a reason decimals 84 instead of negative 84? Oh wait, yeah, I'm stupid. Never mind. I'm stupid. I don't want to talk about it. Yeah. For whatever's in this computer said negative x minus y, we flip x bits. Um, well, okay, so um, compute. Oh, if it said to compute, you wouldn't have to flip the negative x because it'd already most likely be in two's complement. What we do is you would flip the y because we only were taught how to add. Subtracting, someone was saying there's like a bunch of like carry, you have to like pull out like actual subtraction and stuff, and it's just like super confusing. So in that case, I mean, that's what this problem is saying, right? It's saying there's a negative x and you're adding, or you're subtracting a positive y from it, which is like essentially what you asked. So we just flip y, add one, and then turn it, and then just do add. So if you said negative x minus y, you would take y, you would flip it, and then you'd add one, right? And that ends up just saying like you're doing y complement plus one, and that's your answer. You would just solve for this, and you would get your proper answer. Does that make sense? Yup. Say x. Okay. Say x was 0 1 1 1. Cool. X is 0 1 1 1. Then we'd still have to flip it to make it negative. No, because they wouldn't give you 0 1 1 1. If yeah, I mean you flip, yeah, then you have to actually add them, Miguel. I just didn't do all that. Um, I mean, yeah, okay. If it gave you a positive number, I guess, and it said like negative in the beginning, then yeah, technically you should flip it. But yeah, you would flip it. That makes sense actually. But they won't do that. They're not gonna do that. They're not insane, I think. Maybe. But yeah, that actually makes sense. So you would do like 1 0 0 0 and then plus 1 1 0 0 1. Does that make sense? I think. Yeah, I wouldn't expect to see that on the test. I wouldn't worry about that. Okay. Logic design? Cool. Cool. They were just saying like if you have negative x minus y and x is a positive number, then you would flip it to negative and do a bunch of other stuff. Don't worry about it. It's not gonna be a question on the test. I like 99% sure. Um, Yeah, there's like other forms, like there's other subtractions and stuff like that, but it's just like stuff we didn't learn, so I wouldn't worry about it. Um, anyway, we're gonna go on to logic design because that's super interesting, obviously. Um, logic design. So everyone understands that you just take whichever ones are positive, and then you produce, like you take their values and you produce them over here. Does that make sense? Everyone good with that? So that turns into all these. There's only 4 of them. Did I do 5? I did 5. Shit. Cool. Yeah, a bunch of 6B stuff. So it wasn't, oh fuck, I did the wrong ones. Those two. Cool. He had a final until just now. He just got out of his final. He'll probably be here in like 30 minutes. In Gasco we trust. Fuck Gasco, dude. I'm so done. I'm so glad I'm done with the 6 series, 6B and 6D and 6N. Okay, cool. Does everyone understand logic gates? Is like the biggest problem just like simplifying them? Okay. Yeah. Um, yeah, I feel that. Simplification's a bitch. I thought I simplified enough on the first quiz. Like I had like 3 things left, and then she's like, "Oh no, you could just put B," and I'm like, "Oh, that's funny." Um, yeah, Cara, that's the so like this would be the this table right here would be what makes that. Obviously, I didn't put like the different letters and everything, but yeah, yeah, Hollow. That's what I put too. I think. Wait, no. Wait, yeah, I think that's what I put. I don't remember. Um, why is there only 3 inputs? What do you mean? There's A, B, and C, right? And so like this is what they would give us, this table right here, and then they would say like make a circuit design using using the table. Yeah, I mean like it's not for the stuff we just talked about like in class last week. It's for circuit design. You would use it for circuit design. Yeah, like Bailey said, the question would be like, here's a table, right? Turn this into some formula for F, which is this part, and then turn this into a circuit design. This formula I got from that table, right? Like this, right? That part it came out of here. Does that make sense? E, re, okay. So just put a diagram next to the table. No, I mean, technically it is. I just didn't put all the letters and stuff. Right? Because you would have to put like all the letters for all of them, and I just didn't do that because I was lazy. Sorry. Um, the Ying's out here trying to be upset, but we don't even know who the fuck he is. Um, cool. So we can talk about simplification because that's important. Did I post? Is the right one? Looking at the wrong one. That's funny. Cool. This has more stuff. I think the one you did is yeah, Hollow. That one was for part B. Um, cool. So we can talk about some simplification because yeah, it sucks. Um, so yeah, does someone want to give me one to do? I don't like. I honestly like hate logic design, but someone want to give me one to do, and we can go through it. Or it could be one of the quiz questions. That might be easier. You just want to do. You just want to do the full question 3, maybe. Question 3. This is on version A. Cool. So we're gonna do this question right here. Excuse me. Okay, let's do that real quick. Let me insert another image of your body. Cool. Um, so yeah, so I'm gonna just take the formula because we understand this part, and we'll go from there. So we have A complement B complement plus C plus A complement BC complement plus A complement BC plus AB BC complement ABC. Cool. So that's where we at right now. Um, okay, cool. Yeah, I really don't like project design, but let's see what we can do. I would like if she gave us like all the rules and stuff. That would make it super super easy. Um, so let's just say that we can take out an A prime here out of BC, BC complement, and BC, right? And then you have A, BC plus A, BC. And then cool. Uh, take out an A here. Cool. Um, fuck. A, not A, or not AC, or back to the interviews. Okay, that's what I wanted to do. But okay, cool. So yeah, so you can do this one, right? So BC complement plus C, that turns into 1. So this is just a B. Um, thank you whoever wrote that because I suck at this. Um, cool. Either or. You can take out the AC. Can you? Oh shit, you could take out the AC. That makes sense. See, that's why this thing I suck at. So if anyone has better explanations, like someone wants to go for it, which is also 1. So then you get AC here. And then, is that the answer? I really feel like it's not, but just redistribute. Is that it, really? I feel like that's not it. Is that the answer? Oh shit, it is. So put a little mark there like I'm supposed to. And one there like I'm supposed to. Cool. Okay. I mean, shit. Yeah. Thank you for help. 6B, super easy course, but this part kind of fucked me. Yeah, but this one was, I guess, pretty simple. It was just distributing and stuff. But I mean, I put all the rules there, right? So just kind of remembering those. Um, yeah, good luck on this portion. It's honestly practice. Like this is the one I went to the professor once at her office hours, and this was what it was for. Because I was like, I have no idea how to do this. Like, what's good practice? And she's like, no, she won't give us the rule table at all. No, yeah, no, she'll tell us to fuck off. Um, so yeah, just try your best. Try and remember some of the rules. If you can't, then yeah, good luck. Um, I mean, luckily they're not terrible, but they're just a pain in the ass sometimes. When they're super, yeah, it's like how to use it. Yeah, no derivative tables. For every simplification, you essentially lose the circuit point. Yeah, Bailey, it's true. But anyway, so there it is. Oh shit. Does everyone? I mean, what do you guys want to do? You guys want to do another one? How is um which rule is that? If it's like a times a plus b, that's a not a b c plus a equal to a plus b c. Well, because it's either gonna be true on one side or not true on the other side. Does that make sense, Thing? So if you have not a b c plus a, right? Then you're looking at it's either has to be it's a is either going to be true or not true, right? And so if it's true over here on like if it is true, then that means that the equation's solved. And if it's not true, then that means that you need B and C. So it's just B, C plus A. Does that make sense? Okay, cool. It's honestly just like really like thinking about it, which sucks because everything else is kind of like memorization. So are we good on that? Logic gates, we just need to know the different ones. So it's like the or, the not is just the triangle. They look really shitty, but it's cool. And gate. Um, XOR is the two lines like that with that's XNOR, and then XOR is just that one. Cool. If everyone's good with that, we can just keep going. Mux is everyone solid with that? XOR is if they're different, right? So if 0, 1, 1, 0 makes those true, and then 0, 0, and false. And then XNOR is just the opposite. This is XOR, XNOR. Cool. 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 Mux is everyone's good with that? Yeah. The truth table, it's the same thing. Super easy. Cool. We can just keep going, I guess. I didn't hit this page. Delete it. Cool. So decoder, same thing. Everyone good with decoders? They're pretty simple. Yang, we were just kind of going over like the lecture notes, and then if people had questions from the quizzes like related to this stuff, we could go on. It wasn't like specifically like we're gonna go over the quizzes at the end, but mostly just the assembly part. So if you have a question about a quiz that like relates to this, feel free to ask. You can pull them up. How long will this session be? It'll probably be till like 5, 6, maybe 12 hours. Fuck that. I'm going to sleep. We got an 8 a.m. final. Do you think we need to know how to make an adder? Yes, 100%. Not like the internal stuff, but like out of XOR gates, no. I think if you know how to make it out of like a mux, in terms of like a 4-bit adder subtractor thingamajiggerbob, then yeah, you're fine. Oh shit, you guys have the later 45C class. Rip. Like a ripple carry, yeah, that's what I meant, TM. Yeah. Number 2, part B on quiz 2. Number 2, part B. It's quiz 3. Okay, cool. Hold on. Quiz 4, quiz 1. Did I open a quiz 2? Oh, I did. Shit. Okay. To part B. This is part B. Okay, so so yeah, so let's go over that real quick. I guess I'm putting a page back. Cool. So the question, you understand part A though? Um, Sling. Okay, cool. So we're just gonna we'll do this. It says okay, S1, S1, S0, and then a Y. So we know Y is our output, right? Okay, we say okay, Y is our output, and this is 1, 0, 0. Move this. It's over here. Cool. And then we say S0. Do you understand why those values in the B are the same? Or why they're those values thing? Or, wait, those are what they gave us. Never mind, that's super simple. 0, 1, 0, 1, and then 0, 0, 1, 1. Right? So pretty much what this says is we're given an S1 and an S0. That's over here, right? And so we have our selectors. We have 0, 0, 0, 1, 1. Okay. And then from there, it's like, okay, which ones are true? So we see that it's true when we have a value of 1 and 2, right? Because this is these two together right here. These two are equal to 0, and these two are equal to 3. Does that make sense? So if that's true, then we know that when it comes out and it goes up like this, in both of these cases, it's true. And that's what the line as a bar up there signifies. And then we know that these two, right, are false. And that's all that that signifies. Yeah, it goes down in in an upside down triangle for false. So yeah, and up with a line bar at the top for true. So Kara, we see right here, and this one is the like when those two are one, it's true, right? Do you understand that? Okay, so just think of it like this: an output Y is true when it has like a high value, right? And so in this chart over here, it says, okay, well, this is when it has a high value, and when it has. Does that make sense? Okay, cool. You said yeah. Okay, I think you said yeah. Okay, so from there we say, okay, well, Y has a high value when S1 and S0 are both 0 and when they're both 1. Does that make sense? This chart was given to us, so it's just like, it's just in this case. It's just the truth. Kind of like, yeah. So like she was like, this chart was given to us, and like it's this one right here. And so you just kind of follow it along, right? So you say, okay, well, it's true when both are 1 and both are 0. So it's 0, 0 here and 1, 1 here. And then you just signify it with this line, right? Like this one. And then otherwise it's false. And that's these two like that with this triangle. Yeah, that works too, Hollow. So lost. What it's saying there is like, okay, I can do my own example. Let's try it. Value only gets outputted at first 0 and 3. Yeah, exactly. So it's like a function, and it's saying that when it's 0 or 3, the value is going to be outputted. And so in the case, you just do it like that. You don't like the overlapping stuff. Let me see. Does that make sense for everyone? You're good? Maybe? Cool. Yeah. Yeah, they just number them. If you drew it, you could us. Can you go for part A, same problem? Yeah, okay, give me a second. Um, so for this one, yes, the triangles are a complement. Okay, so let's do part A real quick. So it gives us a decoder, and it says, okay, if it's you got y0, y1, y2, and then y3, and then it says you're given an s value, and you know it's 2 bits because it says 2 to 4, right? And then from there it says, okay, here's your table. You have s, you have 0, 0, 0, 1, 1, 1. And then you have your different outputs, right? So you have y3, y2, y1, and y0. And you're just saying, oh, okay, that might be a good idea, yeah. Yeah, let's say y0, y1, y2, and y3. Okay. So pretty much what it's saying is like, when is y0 true, right? It's true when 0, 0 is a case. So that makes this a 1, and this makes everything else a 0. We say, okay, well, when is y1 true? Well, it's true when we're given a value of s1, right? So it'd be 0, 1, 0, 0. And then, well, okay, well, when is y2 true? Well, that's true when the s value is equal to 2. So that's 0, 0, 1, 0. Same thing for the last one. Well, why is 3 true? It's when both bits are 1, 0, 0, 0, 1. Does that make sense? So, yeah. Okay, cool. Andre, what do you think? Yeah, there's only one true value at a time. Y is just the output. It's a selector sort of thing, right? So like only one value gets selected. And the Y is just, explain the 1, 1 part again. Um, yeah, it corresponds to the Y number. Yeah, 1, 1 in binary is 3. Drew. So cool. Miguel posted a picture. My question is that picture. Wow, that looks like a really fucked up question. Um, okay. Let's bring it over. Bring it over here. Okay. 156 times 4, 1 to the 8. Okay, cool. It's a 2-hour final. Do you have to know how to make a mux? Not the internal SASWA, but you have to know they work. You have to know how they work and why they're used and stuff, and the truth table and stuff. So I guess kind of. You just don't have to like know how to build them. So what is this question about? What do you want me to do? Do you want me to do it or explain it? Can I just explain it? No, Young, you don't need to know under the hood. Is it correct to make a 118? Yeah, that would be right. I mean, like assuming all the other stuff is true, like these bits go in here and in there, all assuming all that stuff's true, then yeah, that's you would have to use 8 total. Cool. Yeah, yeah, yeah. It looks fucked up. They're not gonna. I hope they don't ask a question like that. That'd be really messed up. Cool. So we talked about decoders. Um, do we understand adders? Why like this is a thing? Cool. Yeah, latches I think are after ALU design. Um, number one. Number one on what, James? It's one. Which quiz? Quiz 2? Okay. Okay, for sure. I think I put that problem down here somewhere, or I put one similar to it. Cool. I think this Wi-Fi is really shitty. Cool. Let's add another page. What page is this on? 4. Um, cool. So for this problem, right, we have Q1 and Q2. Miguel explained it really well there. Someone posted a picture last night that was like a really, really good picture explaining it. I don't remember who did that, but whoever did, that was solid. If you have it and you're here posting it again, I think it was H-Rod, yeah. H-Rod, are you here still? Is Q1 flip flop? Q1 is the flip flop, yeah. So for example, it just follows the rising edge, right? So D is here, and so on the rising edge of the clock, D is high, and that's why it changes here. And so again, on the rising edge of the clock, it's high, so it stays. On the rising edge of the clock, it's still high, so it stays. On the rising edge of the clock, it's low, so now it goes down. D latch. It just follows it, right? So when the clock is on, it's following D. So it goes, and then here's the clock. The clock's on, right? And D is low, and the clock's on. So we follow it, and then D gets high here, so it has to get high here. And then we follow it. Now the clock's off, so it's just going to keep going. And then the clock's back on. D is also high, so we keep following D. And then we come down here because it goes down. We follow it, now the clock's off. So we just keep going, keep going. And then all of a sudden, clock's up again. We follow D, so it's up again. And then we just keep doing that all the way through. Does that make sense? I always get a out of you. It's like a questions. Let me link. Okay. Bailey, if you link, I'll pin him. Yeah, I feel that. Honestly, if it was out of my memory, I would just probably not. Yes, that's why D flip flop follows the it follows the rising edge of the clock. So whatever the D is at the rising edge of the clock is what it's going to go to. And latches just follows. So when the clock is high, whatever D is doing is what you're cool. Um, let's see. What are we talking about? Someone had a question. Can I do the register one? That's like the next one. This one, right? Part B. Part B, registers are flip flops. So just know that they're flip flops. So in this case, right? So in our enable here, we're saying, okay, well, the enable's high and the clock's high, right? But it's not on the rising edge. So now the enable's high and the clock's high, and so it changes here. Does that make sense? So it follows. It says, okay, enable's low, so we're not doing anything. Okay, now enable's high. Well, this clock cycle is high, but it wasn't high when the enable was also high. So you have to you don't do anything, and then now enable is still high and the clock signal turns high, and we just follow it down. We make this into OE9 because that's what's here now. Like when enable changes, it changes. Enabled and clock, the enable needs to be on for it to have any effect. It's like this idea right here on the decoders, right? If enable is 0, then nothing happens. But if enable is 1, then it's just it's a D flip flop. So, yes, that's why we do need to know. We do need to know how to build registers, if that's what the question was. I don't remember. And enable isn't what changes, but if enable is up, but clock is down. No, enable is the one that like determines. Wow, T out here with these like anecdotal examples. This is great. Yeah, so if it's enable, it's like it's plugged in, and the clock is like what actually like turns on the light bulb, something like that. And then if it's not enabled, then it's unplugged, it's not doing anything. I don't think I've gotten to that part yet about latches. Yeah, that's the next part. So once we get there, we can talk about that more. But cool. Are we good on this part? I think we're just gonna keep going. How do you draw a D latch? Well, if you right here, hold up, let me get rid of this page. Right here, this is how you draw a D latch. And then we can pull it up on the quiz too if someone said it was 2B. Then maybe it was on quiz 2. Maybe. Maybe not. This is, I think it was 2B of the quiz. This is where I have a question like that. Maybe, okay, just find the question and tell me which one it was. I don't, are you talking about 2B? Like 2B is the one we were just talking about, I think. This one, the register. They said that we might, okay, let me look at version 2. They said we might have to know how to draw D latches and stuff, like know the inner workings of them. Um, but I mean, meh, you know, 2B. This is 2B. Is that what you meant? Quiz 2 version B. That's what this is. This is quiz 2 version B. Number 3. Okay. What's your question about this one? Like just how it works in general, or hold on, taking a picture. Okay. We're on hold. As far as this, it was the first thing we talked about. It's a NOR, right? So it just says like if you're given an R, why'd the pointed one change? Was that even on the quiz? Oh, quiz question 1B. It didn't change. Is your question did why did it not change? Okay, so let's look at it because okay, I'm gonna talk about it because you're talking about the point E9. So you're talking about here, right? Like it should have changed, or why did it? Like you thought it should have changed. Okay, so let's follow the line, right? So okay, so we're not doing anything because it's not enabled, right? It enables. Okay, now we have to be careful because it's gonna do some stuff. So we follow it. Okay, here's the rising edge. It enables. Change it to 0, right? Okay, we keep going. It hops down. We don't do anything. We don't do anything. We don't do anything. Okay, it hops up. Now we need to pay attention. We get here. Okay, they're both up, and then now it's 0.35. Enable is like the big, like, kill switch. Yes, only the value at the beginning of the clock. Correct. Yeah. Yeah, and this one, I mean, it's close to 0, 1, but it doesn't. Oh no. Shit. Mm. Is that my car? Yeah, it's my car. Yeah. I wish cars all-wheel drive. You can't drift, bro. Flex. Dude, I wish. I'm gonna wrap it this summer actually. Y'all talking about expensive hobbies. That's really expensive. Spend way too much money on my car. Um, wrap. Like wrap the color of the car. WRAP. So it'll be a different color. Yeah. Cheaper and I personally like it better just because it's not gonna ruin anything. My car. Damn. You the one keeping all the kids in there? Joda out here. TM, do you have a lot of tattoos? Makes sense. All right. Solid. I would hope so if you're gonna spend all your money on tattoos that you want them. Honestly, I love my car a lot. So I put like a lot of money into it. My old one was like my old car was like 550, 600 horsepower. So like that was built. It was like another Subaru, but I built that one, so it was special to me. But I'm gonna do Nardo gray, so like the Audi gray. It's fine. Um, he's talking about a tattoo. It's like, yes, like I'm going over assembly stuff. I'm just getting distracted. Sorry. Yeah, if you pay 30 bucks for a tattoo, then like you should be very um because that's probably not going to be a really good tattoo and something's really fucked up. Half sleeve can get pretty expensive. 00 straight up decimal. What if for the decoder, if S is 00, Y is the output 00? Because okay, so Sasquatch, look at the Y. The Y is has a value of 0, right? So the output ends up being like a 0. So Y3 isn't enabled, Y2, Y1, but Y0 isn't. And that's why it's 0001. For sure. For sure, for sure. Not connecting that. Uh, close connection. Connect. Allow. Cast. Start broadcast. Okay, cool. How do I roll school? Damn, you the real winner here. Correct, Joda. Correct. No, it's just talking about like the decoder just talks about which one. So with a decoder, you're just saying like, okay, well, you're just picking one of them. So that's all you're doing here. Okay, cool. Um, I mean, the thing with D latches and D flip flops, you guys should. I mean, it's just kind of like something that you kind of have to understand. There's not like really not really like a set like here's a bunch of problems on how to do them. Yes, that's why we're gonna go over those a little bit later. Um, So yeah, it's not like there's a set anything. It's just kind of like you have to understand that a flip flop gives a inverse clock and why it does. I mean, they'll draw a picture to help of DRAM and SRAM ago. Or of the D latch. Oh, the D flip flop latch. I mean, yeah. I mean, like this is what they are here. It's just like it's just dumb, you know. But okay, we can let Miguel do that and come back to it in a second. So registers, they're kind of cool, right? They have D latches inside. Super super cool. Um, yeah. So yeah, you can tell none of us want to study that. Feel that. I thought registers had flip flops. I'm sorry, yeah, they're flip flops. I'm stupid. I didn't mean to say latches. You're right, Tim. Thank you for correcting me. Yeah, I was burnt after the first final, honestly. It's the only one I'm worried about. Thank you for the video. Um, Pretty much, registers, they take a clock signal, take a load signal, take an input, and they give an output. Um, I already pinned the video. I got you. So in this case, right here, this one, right? I don't know. It's kind of you have a clock signal, right? Oh, that's not good. You have a clock signal, and then it goes there. If the clock signal is 0, it's taking the data, right? And then it gives an output. See, this is what I followed off her instructions, but I don't feel like this is right. You know what I'm saying? This is definitely not right. Because I don't feel like you would do. I feel like something's wrong here. I don't know. Tio, is this wrong? I feel like you would know.
Sorry?
Is this register right here? Is this wrong? I feel like it's wrong.
Go take a look at quiz 3 to look at the questions
Right,
that we have
let's
to
see.
do for that.
Quiz 3. I mean, we didn't actually have to draw the internals of it. It's just something that she drew
Yeah.
on the final review, I think. I'm not like super worried about it, but I don't know. I think
Did she draw that image in the?
that's how she drew it, but I don't think it's right. And
So those
knowing
two,
her, I
the
feel
two
like
bits are coming out of each, because each of those are 1-bit registers basically, and
correct,
so
yeah.
both the Q0 and Q1 are getting fed into some other wire that takes both of those together.
Yeah, and
I think that's what
that
she's
makes
saying.
sense, but it's the fact that the first clock signal is not taken and the second one, you know what
It's
I'm saying?
choosing between them.
That's what I don't like about it.
Mm.
Yeah.
So it's saying it's a 2-bit register, but it's only taking one of the bits. That's what this is showing.
So, I mean, like if
That's
both,
awkward.
yeah, if both were inverted or
If there
both
was no,
weren't,
yeah, but
and not inverted better, but I don't know, let's look it up.
I think she's trying to say this is a 2-bit register file, and it's like it's choosing between one or the other for
I feel like I can't type. I feel like let's see. To me, this looks like they're all
See, the
supposed to
clock is
be.
all the same for those, right?
Yeah,
Yeah.
yeah. See, like that
That's
makes sense to me.
that would make sense, but I
Okay,
think that's probably what she meant to do or something,
okay, yeah.
but that makes sense.
Stalking G on Twitch. Okay, yeah, that makes sense to me. Cool. Cool. Okay, so yeah, so let me fix that real quick. Thank you, too. Do we need to know the internals for ROM and RAM? No, we're gonna have to know the internals for ROM and RAM. I would fail that. Cool. So yeah, I mean, in that case, like what it's made of, I think that was in terms of the registers, and in terms of like ALU and stuff, like what makes up ALUs. Because the only thing, I mean, we talked about it in class, but I feel like a large portion of the class had no idea what she was talking about because she was talking about what not transistors, I think, maybe, and a bunch of other stuff. ALU design is just a bit adder. ALU design can be a lot of stuff. Like an ALU design problem. This one right, quiz 3. This is ALU design. Yeah, exactly, Joe. I was like, do we want to go over this first problem, or I feel like Yang's gonna say yes, but yeah, there it is. Anyone else want to go over this first problem, or we can go over it real quick. I mean, it's not that. So like the first one says, okay, if you have a selector, if your selector is 0, 0, okay, then we're doing A plus B plus the Cn. And so that's what it does for the first one, right? You have A plus B plus Cn. For if the selector is 1, then you have A minus B, right? Which is just saying A plus B, B complement plus 1. If the selector is 1, or 2, sorry, then you have not B. And if the selector is 3, then you have A XOR B. It's just showing that. I mean, it's just putting in all the signs. Does that make sense? What's up, Bailey? Keep forgetting I have to like not let it die. I got for doing Cn equals S0. Because the Cn can technically be true, could be 1 for the A plus B plus Cn, right? That's the only reason you lost points. It's just we know it's 0 if we're or we know it's 1 if we're adding or subtracting, and we know it's 0 if we're just adding, but it could technically be the additional. That's the only reason that you would have lost points. So for an adder problem, so if we say A plus B, we can say that's an adder, right? And if we do A B, A minus B is equal to A plus B complement plus 1. It's not saying that it's going to be 2's complement. It's just saying that like these two problems, this and this, are equivalent. That's it. And so that's why for this part right here, it has the 1 here, because when we subtract, you know you have to add 1. And that's it. Yeah. Already plot twist. Just get like everyone in the Discord complaining about how final is. 100 and like what? How many people do we have in here? 100 and like 40 some. 140 some people just complaining about how hard to find. 142 in here. Yeah. How hard the final is. Like everyone press good note. Legit the most like controversial post ever. Yeah, we have more than half the class in here actually. I think there's 240 people in this class, like roughly, and we have 140. 142. And there's a lot of people in this chat right now. Are they all even active now? But oh, for like future classes, hello? Yeah, okay, real quick, I'll just pause for a second. Um, I mean, still, that's still a decent bit. Oh my god, that shit was like 5 minutes ago. Thank you though. Sorry. Okay. For 51, if you guys have any people fall, or you're retaking 51, I have a friend who's gonna take over the channel, or this Discord. Um, they're not taking Longma, so they're taking the other professor, but I still feel like any 51 communication is helpful. So totally up to you guys though. If you have people you want to invite or whatever, feel free. Or you want to stay in here. But and also making a CS 178, which I'll post pretty like in a couple days. And then I'm also making a CS 132, and that's it probably. So 132 and 178 are the two that I'm making for next quarter. And I'll post that and pin it where no one else can type, so it'll be super, super like obvious where they are. And yeah. Anyway, that's just like a little side note. Cool. Register files. Are people good on register files? Maybe. I'm not gonna lie, I really couldn't find any that were super helpful. It's kind of like, do you understand how to build a like what a register is, Lot? No. Okay, so you have a register, right? It takes a load signal, it takes a clock signal, it takes an input and gives an output. So that's like one register. A register file is a bunch of registers. Does that make sense? Okay. So it's literally just doing a bunch of them, right? And instead of having just an individual load for each one, we take it as an address right here, and we use a decoder to choose which one we want to use, right? And that's what the load signal is. And so from there, we just have to take that same 2-bit address, and it's also over here. And so you just know you're choosing the right one. Does that make sense a little bit more? It's like they all take the same inputs, and they all take the same clock signal, and they how you give an address which chooses which one register you're looking at, and then you also have to choose out of their outputs which one is the right one. You use decoders in a diagram when you need to select one out of many, right? So we need to select only one of these registers out of the 4 that we have. The mux is used when we have a bunch of data and we're only trying to choose one. Yeah, so the decoder is choosing which register is getting data loaded into it, right? Does that make sense? So think of the load as like an enable signal. Decoder is less to greater and mux is greater to less. TM, a decoder is going to be, no, decoder is going to be 4 to 16. So for this one right here, yeah. So this decoder right here is a 2, right? Because you're given a 2-bit input and you have 4 options. And the load goes into the mux at the end. The load won't go into the mux at the end. Technically, it should be this address, right? Because if we write anything to a register, we want to make sure it's the same data that we're reading out of it. So this one and this one should be the same technically. So, Kara, the decoder is lesser to greater, right? So you have a 2-bit decoder, right? If you have 2 bits, there's 4 options, right? Because these are all your options. That's all it's saying. So you have a 2-bit thing and you have 4 options. The same idea if you have a 3-bit, right? So if you have 3 bits, um, you have 8 options. The I on the top of the register is input, like input data. Decoders are used to select from multiple options by selecting only one. And muxes do the same thing but kind of reverse. So they take in a bunch of data and they have a selector that um, chooses one of those pieces of data. Mux is always Q is greater than R. If Yeah, okay. So the difference, yeah, Yang, is that like let's look at the two individually, right? So like I'm gonna scroll up right here. Look at a decoder, right? If we ignore the enable real quick, yeah, let's ignore the enable real quick. It takes in one. It has two things, right? It has like one input and then a bunch of output, right? And if we look at a mux, right, it has not only the inputs and an output, but it also has a selector, right? So a mux has an extra thing, an extra selector, where a decoder only doesn't have that selector because the selector is the 2 bits that go into it. And that's where the difference is. So you can't technically say that they're reversed because a decoder only has like an input and an output, and a mux has an input and output and also a selector. Yes, laws. It should because like it makes sense, right? If you follow the register file, whatever register that you're writing to, if I can find it, whatever register that you're choosing from the decoder is also the one you want to read from, because you don't want to like choose a register, do something to it, and then read from another one. That just makes sense. Then like it's just like at a complete random, and you're just choosing a bunch of random shit. The case where we start like having different addresses for reading and writing is when we start looking at the actual like instructions, right? Because in this case, for this register file, we have one register, two registers, three registers, and that third register is a write address, right? And so that's where a selector might be a little bit different, because in that mux you're choosing a different selector, right? So like up here it's simplified because we're just saying, oh yeah, we're choosing something else. But down here, it's like it explains the entire thing much better. Up here, we're just saying like, oh yeah, it could be different. The decoder's input is a selector, yeah, to choose which one is getting selected. I don't know, yeah, I think it's posted somewhere. Oh, look at Tio out here. Tio, I feel like you're always on the spreadsheet. Like, I feel like every time I log onto it, it's like you're there.
Oh, it's just always one of my tabs, so I don't lose it.
For sure. There you go. We haven't gotten a quiz score yet, right? No, we haven't gotten a quiz score yet. But yeah, it should be right now for everyone if you put in your scores. But yeah, cool. Okay, after register files, memory design, RAM, ROM. You guys want to go over that a little bit? I think someone wanted to go over that. We can go over that. So it's the same thing as a register. Honestly, the register file, it's super similar, right? You have a decoder right here, and that's used to select which one of the RAM, ROM things that makes sense. So in this case, it's saying that it wants us to take build a 512 by 8-bit ROM using 1 by 8-bit ROM. So we're like, okay, well, we need to have enough to make a 512 by 8, right? And so it also tells us that it should have a 9-bit wide address, right? So we're saying, okay, our address is going to be bits 8 to 0, right? And then from there we say, okay, it's going to be 8 to 0, but the 120 by 8 only takes in a 6 to 0, a 7-bit address. We're going to have to do something with those other 2 bits, right? So right here, we section off those other 2 bits and we put them into a decoder. And then we just give those other 6 bits normally to an address for all of them. Does that make sense? If there's any questions, just stop me. I'm just going to kind of keep going. From there, right, in this case, it's ROM, which is read-only memory, so there's no write data. So in other words, all these AND gates with the chip selector, we're just saying like it's more like a load / enable / chip selector. So like the CS value can be 1, and then if we also give it a 1 out of one of these, then they'll be ANDed together, and that's the one that we choose, right? And then because we're choosing out of one of 4 ROM, we also, using the decoder, we also have to take those 2 bits and put them in to it like that. Is everyone good with that? Kind of. Yeah, I like it. I like it. Yang, why are you complaining so much? Go complain in the off-topic chat.
Damn, dude, getting called out.
Lab 2 was corrected to 13 out of 13. Still triggered. Hollow. I don't know. The best way to think about it, I feel, is just like it's a register file, but because we have another input, you have to, because you have the chip selector as a second input, you have to AND it with something. This diagram's of a ROM. This is question 2 out of homework 3B, I want to say. And then Jared, yes, you take the other 2 bits into a decoder in order to determine which one of the 4. So yeah. And then I didn't do the other one, but for a read write, for a read write, which is somewhere. Register file. Okay, we didn't do that. Let me see if I. Wrong. Okay, so for this one, um, this is a RAM. This is RAM, right? So the difference between RAM and ROM is that it has a right. And so in this case, because we're still using the chip selector and our decoder, we AND them together to choose which one of these RAMs we're looking at. The read-write signal just can go in normally, and we don't have to do anything to it. Is everyone kind of good with that, with RAM and ROM? TM, you don't need to worry about SRAM and DRAM, just no RAM. If we do and I lied to all of you, then I apologize, but 99% sure. TM, we don't need to know about SRAM and DRAM is what I was saying. You don't need to know the difference, just know that there's RAM and there's ROM. The difference between RAM and ROM is more important. Yeah, exactly, Joe. The difference is it's the way that they're built internally. And it's a pain in the butt. CS stands for chip select, and it's just choosing which ROM you're going into. Yang, there's still going to be a curve. I don't know what you're talking about. It's probably going to be like 5-ish%. No, it's not computer science. That's toxic. Yeah, so it's just chip select. It's like a load input. If she doesn't curve, I'd be really, really surprised, honestly. They got like a really fat curve last quarter. Yeah, she's curving. Yes, whatever Tio put there, the chip select equals an enable signal is super important. That's pretty much what it is. It's like the chip select is like the enable for register or the load for register files. All right, we're gonna keep going. These thingies. How does everyone feel about these things? I agree. They're meh. All right. See you later, Sling. Um, do we understand how these work? Do I need to draw them? Not cancel. Yeah, we're still going over the assembly. That's probably going to be after we do these because I think that's it after. Team, I don't think Ahmad's in here. I don't think you need to be like kissing his ass that much. Like honestly, I'm not Ahmad. I'm not gonna bump up your grade. At Eli. Oh, she is in this though. I'm gonna you delete that. Okay, cool. Being toxic. What if what if I was a mod? What if y'all were just getting screwed right now? You would have to talk slow. What if I just talked like really like slow during discussions and used Wikipedia a lot? Huh? And then like here I just like totally taught you guys everything. What if there was that? What if it was just a big mindfuck? Eli is in here though, yeah. And you know I don't go to your discussions. Yeah, you're right. I don't have a sarcasm. Jay is the prof for the voice changer. Yeah, that'd be pretty funny actually. Her accent was still going through. Just host, dude. They should do that. Lectures over Discord would be awesome, actually. We should all just like be in here. This should be class, like straight up. She could hop in here to and just teach everyone or try, and then we could all work together, and then Tio could just come out of nowhere and just teach everybody. Tio's big brain out here. I don't know. Okay. Yeah, that'd be smart. It's not my face. I mean, there are already YouTube lectures and shit. I was thinking we were talking about that. Like, I'm gonna post it. Actually, I should probably post it today so people can calculate grades. But I'm gonna post on Piazza to see if people want to input their grades in like a spreadsheet, and so we can see like how many people see like the differences between scores and stuff, and then we can just put like an average. Um, I don't know how many people will do it, but I mean, yeah, for the assignments, but like just in general for like what people have in the class and stuff, it'd be interesting to see. So, and I mean, the difference between the people who are using Discord versus the people not using Discord. I feel that, Joe. I fucked up a lot. No, let's see, Discord user grades. Yeah, we'll see. That'd be interesting, actually, Sling. I'll post it today, and then we'll see. Okay. Are we done then? You guys not like we can just talk about the assembly stuff? Okay, let's do assembly. Let's do it. Okay. Quiz 3 assembly. Let's do it all. Let's do it all. Quiz 1. Cool. Quiz 1 assembly. Is everyone good on this one? I feel like this one's like super easy. You just had to count. Like straight up just count. You know what I'm saying? Are we good on this one? Or do you want me to go through it? Okay, cool. We're gonna go on to the quiz 2. Because yeah, quiz 1 assembly was like just follow the numbers. It wasn't that bad. Quiz 2 assembly. Okay. What's being loaded into T0? Okay, I can go back. Hold up. I don't remember which one it was. It wasn't this one. What's going into? Oh, by the way, here's the appendix. This is what was at the bottom of the test. If whoever was asking for quiz 1. But let me pull that up again. Quiz 1B. I don't remember which one it was. Are these? Oh, it's in the homework problems. Quizzes. My bad. Okay. What's loaded into T0? Is that what you're saying? Somebody? Bailey? Okay. The appendix was definitely 100. Like it was on the quiz, for sure. It was on both versions. I'm sure of it. So T0, you're just loading this really, really big binary number, right? And it's a hex number. But you pretty much all you have to do is you convert it to decimal. So for example, or to binary, I'm sorry. So you're gonna write 0. Oh shit, that's harder. You're gonna write 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 And then you're just going to keep doing that for all of them. And that's going to be your T0. And then once you wrote out that, you just had to iterate through it, and then it anded something, and then you just kind of go through that. Does that make sense, Bailey? Cool. Like total grade percent. Yeah, I was gonna do that like once we get more people who aren't on the Discord. But you want me to do it now too? The shift right logical shifts it by 4, yeah. Yeah, I can do it real quick. It's not like it doesn't take that long. Cool. Okay, question for quiz 2. And that wasn't quiz 2, it's quiz 2. Okay, so for these problems, do people understand what was going on here or what? Kinda, maybe. And TM, yeah, it drops off every 4. You're chilling. So for this one, right, you just have to kind of follow it. Let's do it. Excuse me. We'll do part A real quick. So we say, okay, I'm gonna just write it out kind of more like not word for word, just more like this. So TO equals 1002, right? Which we'll do the what is that? I think it was F something else. That's 1000. Hex. Oh, 3E8. That's what it was. Okay. So then this is 3EA because that's 10, right? And then we say, okay, that's what T0 is. T1 equals 0x35. Okay, and then we store byte, right? So it says store byte in T1. So store byte T1 in T0, right? And so if we look at the addresses real quick, we see that we have 1000, 1001, 1002, 1003, and then before is 255 for all of them. And then it says, okay, so it says store T1 in T0. Okay, well, it's 1002, right? And so we just look at 1002 and we store it here. So that says, okay, we're going to make this into, I don't know, I have to register there, 035, right? Because it's stored by it. Does that make sense? Whoever said that. How does it equal 3EA? You say 16 times, or 16 to the what? To the second times 3 plus, that's 14 times 16 to the 1 plus 10 times 1. Yeah, kind of something just to remember. Plus, I did it in a calculator just to be safe, but yeah, definitely something to remember. Does that make this question easier if we know that that's... No, you can't bring a calculator, sadly. I wish. That'd make everything really nice. Does that make this question something like more understandable, or do I keep going? Okay, we can keep going. So the next instruction says load word from T1 minus T0, right? So it says load word into T1 from minus 2T0, right? So if this is 1,002, right, we go up to 1,000. And so into T1, we load T1 now equals 255. Does that just make sense? From there, we say, okay, the next one says ORI. So we OR it immediately. And we say, okay, 3FC. So we'll do this. So it says OR T2 and T1. So we know T2, I'm sorry, or T1 with 0.3fx. So T1 we said equals 255, right, which is FF, and this is 3FC, right? And so this just turns into 3FF, if I'm not mistaken. Is that right? Okay. So now T2 is 3FF, right? And so this is close to B. So then we say, okay, we're going to store into the first register, because we say, again, we do store word, store byte, and we're storing T2 into -2 T0, which again turns it into 1,000. So we look up here and we just store the byte, which ends up just being FF. Hold on a second, let me make sure. This is 12, that's 84. I believe so. Can someone confirm that's the case? It's store byte, that's why, right? Yeah, okay, that's why. Yeah, Andre, you're right. Or Eddie, you're right. You just discard the 3 because it just takes the last 2. So when you OR, this is the OR operation right here. You get 1 1 1 1 1 1 1 1 1 1 0 0, and then this gets discarded because you're looking at these 2. So all that goes thrown away, and this is just FF, and that gets stored into there. That makes sense? If it was store word, it would take up all of these, and then it would end up being 0x3f 0xf 0 0x00 I think.
Top one's FF. Top is the
Is
lowest byte. Yeah.
it? Okay, for sure. Thank you. So then it's 03.
Yeah, just like that.
Okay, for sure. It's not by default, it's just what they gave us. They just told us that this was the case. On the problem itself, it says before. Cool. Everybody good with that? Cool. Do we need to do some of these problems, or can we just go on to the next ones? Go on to the next ones, or we good. Okay, cool. Quiz 3. Okay, these were just remembering which ones were which. Are we good on these, or no? I fucking sucked at that. Okay, for sure. Delete. Cool. Memory is always in hex. Sometimes if it has a 0 and then the letter X, it's hex. Just yeah. Okay. So The first one says SLL, T2, T0, and then by some number, right? Okay, so let's look at T2 and T0, right? So it says, okay, I took 0x55 and shifted it left logically by something to equal in T2. Okay, so this is T0. T2 we see now equals 170, right? So we see equals 170. So it's like, okay, well, let's calculate what 55 equals now, right? So we say 5 times 16 to the 1 plus 5 times 16 to the 0, right? It's like, okay, let's see. So now this is a number. What is it? It's 75, 50, 30, 80. It's 80, sorry. 85. Because it's 80 plus 80, or 80 plus 5 equals 85. There you go. So T0 is also equal to 85, right? So 85 times 2 equals 170, right? So if we shift to the left, right, that's multiplying by 2. So 85 times 2 equals 170. And therefore, we only have to shift left once, right? So it ends up just saying like, okay, we're just shifting by 1. So that's the first answer. Cool. The second one says, okay, load byte or load byte unsigned. I'm going to do load byte. It says T4. I actually didn't even have that part yet, so I won't put that. So it says T4, 1, T3. Okay, and so we look at the chart again and we say, okay, so we're putting something in T4 from something up here. And so we look and we say, okay, well, the answer here is 100. So can we find 100 anywhere up here? And they're like, oh yeah, we can. Cool. So 100's here, right? Okay, well now we need to find somewhere where it's 80, right? Because we want the memory address from 81. So we're like, okay, well, which one is that? And you don't really know. So you try and find something that will give you 80. So then you think, oh, okay, well, what's 8 times 16 to the 1, right? And you're like, huh, it's 128, I think, if I'm not mistaken. And then from there, it's like, oh, now I just need to add 1. Wow, 129? And that's what 81 is? Wow. And then you just put that 1 in here, and so you know it's load byte. Does that make sense? Cool. I'm gonna say that makes sense because I think that makes sense. You honestly just needed to. The best way to solve this question is to change either all of the numbers into hex or into decimal. That was like the best solution for this problem, because once you do that, it becomes super easy. You're just like plugging in numbers. But if you don't do that, then you're really like just like making some guesses and stuff. Because the after is in decimal. I mean, you could go either way, honestly. It takes more time to convert it and then go in for it, but if you don't understand where you need to go, the best way is to first convert it, and then you can kind of see where the numbers are correlated. So, okay, so for example, it says the question just gives us this part here. Hold on. This part, I believe, right? Or it gives us a 1, 2. That's important. So it says this. And so we're saying, okay, so something in T3, or actually it doesn't give us the T3. It says some number, right, plus 1, all right? So it says, okay, well, all right, let me try to explain this one more time. We're storing something in T4, right? We know it's going to be either store byte or load byte because we're doing memory addressing here because of the parentheses. So we know that starting off. So it's like, okay, well, what happens to T4? okay, T4 now has a byte or has a value of 100. Okay, well, where is this 100, right? And so we see, okay, well, there's 100 here. So how do we get this number? So you say, which one of these registers plus 1 gives me the hex number 81? So you could go through and convert them all, right? And you can like look and kind of cancel some out. So you have T0, T1, T2, T3, and T4, right? And you say, okay, well, 55 is an 81, AA. And so, okay, now you have 255, 128, and 85. Well, this one is equal to FF, and hopefully you just kind of know that because that's just kind of one that you should know. And then T3 and T4 are all you have left. Well, if you think about it, right, how do you, what's 85 in hex? It's 16, like 4, I think it's like 4 something. So it's not like one that you have to like understand too much. So instead you say, or it's 55. Okay, so it's 55. So again, like that's not one that you just have to you kind of use deduction. And then you're like, okay, well then 128 here. Let me convert this and see what this is. And this turns into 0x 80, right? And then you have to add that 1 and you get your 0x 81 that you were looking for. And then you know it ends up having to be load, and so then you just put it in like that. That makes sense? Cool. You just really have to think about it. But if you try using deduction, like canceling some out, it makes it easier. For SLL, the SLL is just shift left logical. Excuse me. So you're storing it into T2. You're taking T0, the value in T0, and you're shifting it left by 1, and you're storing that into T2. Yes, hollow. Oh, that's what you meant in the first register. Sorry. I thought you meant like T0 as the first register. For sure. You're right then. Cool. Are we good on these now? Do we understand like what you have to do for these problems? Okay, I can do store byte real quick. So it says, okay, store byte into, or it says T0, right? It says this is what we're given for the problem. Okay, so we're like, okay, well, what's in some number in T3 plus 4? We're storing a byte somewhere, right? And we're storing something from T0. Okay, so what is T0 right now? T0 is this. T0 equals the hex 55, which is also equal to 85, right? As we calculate a little bit later. And then we say, okay, well, where is this 85 being stored, right? And we see over here that it's being stored in the hex memory 84. And so we're given 80, as we know that T3 is, because we already calculated it for the last problem, right? And so if we just add 4 to that, that gives us 0x84. Does that make sense? Does that make sense for people? You add 4 to T3, right? Because here we're doing memory addressing again. And so because it gave us T3, saying that we were gonna have to do something to T3. T3 is, yeah, 131. Actually, it'd be 132. and then that is equal to 0x84. Does that make sense? Okay, cool. So if we're good with that, then I think we're solid here. Everyone good here? You just really have to play around with the numbers. You have to take what's given to us, and then, because like I look at this problem, I say any problem with parentheses, there's addressing, right? So I'm going to be looking at the values in the memory and the register values. And then anything else, it's just like, okay, which ones make sense? And you just have to really compare. Cool. Then quiz 4, our assembly question was this one. Is everyone good with this one? Yeah. Yes, like, as long as you don't hardcode the dimensions, but I feel that I did that first, and then I realized that it wouldn't work because something was wrong. Okay, cool. So everyone's solid here too? Yeah, it had to be. For pictures, it's load byte unsigned every time because you're not going to get a negative number. It's just between 0 and 255. Okay. Well, I mean, that's pretty much it then. Unless there's anything else specific. I know someone was talking about building, what's it called? The instructions, at the beginning of this. Does anyone have questions on those or? Yeah, Hollow, that's, you would store in memory space 129, or 081, whatever's in T4. Why do we multiply on the assembly question? You have to multiply to get the dimensions. Because we know that one side of the dimension is, yeah, exactly, like that. So for example, you got 1, 2, 3, 4, and so that's what the dimension is. That's what's stored in A2, and you have to multiply it by itself to get the full size of the array. Does that make sense? Okay, cool. Cool, cool, cool. So yeah. Does anyone want to do the diagrams, or do we just want to kind of ignore it? Or like you understand it? The better answer. These diagrams. Oh shit, I'm hiding them, sorry. Hold up. These diagrams. And in or an assembly. Yeah, I can go over that. Do quiz question jump without branch. Okay, I can do that one. I'll do the jump one. That's the one that I had on my quiz, my test, I think. Okay, but let me do pure esotism question, and then I'll do the other one. Okay, so if you and two numbers, right? Let's just say that you have um, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1, right? When you and two numbers, the first, so this one will be and this one's going to be or of them. So when you and the two numbers, right, it's only true when they're both 1. So you end up getting the bottom one, right? And if you or the two numbers, you get this because because you have all ones up here. Does that make sense? Is that what you were asking? And B, you're supposed to understand the full data path and be able to draw it probably, because it's yeah, because she said, like, when we were doing the final review, like, oh yeah, it might be a good question to ask to draw out a full data path. But if you can do that, you're fine. I mean, I don't think it takes that long. I think it takes like maybe 5 minutes to draw that out. Yeah, Bailey and I were like, we were practicing that for the last quiz. We were expecting, we were hoping. um, yeah, if you know how to draw from scratch, I think that's the best thing. Just get it tatted. I'm dead. Tim, if you ever get that tattoo on your body, that's really like, that might be kind of sad. You know what I'm saying? All right, see you later, Sling. Okay. I'm gonna do the quiz 4 question real quick on here. And then that's pretty much gonna be it. Nice little, everyone can really take a nap or something, or study. Totally up to you. She's not giving a practice final, no. Okay, is this the right one? Okay, so this was part B. Um, wow, they didn't even put the drawing on there. That's pretty sad. Okay, cool. Um, Sample problem for 1C. I can just draw it out. It's fine. I didn't even draw out the like half of it. So stupid. For 1C. Okay, see, this wasn't the question. Yeah, see you later, Tim. Because they didn't even give that to us. They literally only gave it. Hold the phone. Let me just draw it out. Let me take this one. Paste it on here. Okay. They didn't give us a branch. And so here all this. Okay. Okay. Yeah, so there was no branch. So we're gonna do it without a branch. Cool. So let's add our jump signal just because I want it there. No, that's scary. Okay, there's our jump. So give me a second. Let's do this. So from here, you grab your bits, okay, and you pull them up, and you know that these are bits 20. What is it? It's like 25 through something, 0. That makes sense, right? So you grab these bits, and then you shift left by 2, right? And then you also have to grab the first 4 from the program counter. So we'll do this over here. We branch off and we connect them. And now becomes some 32-bit address, right? That makes sense? And so then all you had to do from here, it went into another mux with a 1 and a 0, like that, and it came back, and I think this was the answer. That should have been your answer. This is only a branch, or a jump, sorry. This isn't both. So for this one, this is the jump, right? Because we're not adding anymore. See, yeah. I, that's what I thought too. Like try to think ago. Like I thought like, oh, let me just draw it in there. Like it makes sense. And then I went and talked to the guys, like, just use what you were given. And so I was like, oh, so you don't want the branch? And then he's like, I can't tell you that. I'm like, okay. But yeah, so I just ended up drawing the jump like this because they didn't want to give us a branch and I wasn't gonna draw another line out. Yeah. So this is what it should have looked like. This is pretty much saying, okay, we're taking the jump address here. Okay, we're shifting it left by 2, which we always have to do. And then we're concatenating the 31 through 28, I believe. 31, 30, 29, 28. And so this is all you would have to do. Quiz A had branch, quiz B had jump. So it just depends on which quiz you had. You did not need both, no. Because the question itself asked this. It said, to fully support the instructions in 1C, which is this question, accomplish the missing component. And that's it. In quiz B, it was jump here, and quiz A was branch here. Can I add branch into the picture? I can. I'm gonna have to erase like part of it though because it's not the same. Because in order to add branch, you have to erase this line, add in another mux here, 0, 1. Then you have to, what do you have to do? You have to take these, and then, oh shoot, these bits from here all the way up. And this goes into an add. This goes into the 1. There's an AND gate here that comes from this 0 output and a branch output from here. And then you also have to do this up like that. And that would be branch. Oh, and then obviously you have to connect this like that. Cool. So you guys good with this then? As good as it? Cool. Grades are due not this Friday, but next Friday. Yeah. Alrighty. Or is there any like last minute big questions? Hard. Here we go. Yeeting Travis. No, I don't. Maybe actually. Maybe they might put everything on there. If they take anything out, it's probably gonna be SR latches, just individual adders, and maybe some binary number stuff. You have to know how to make a register. We were talking about that earlier. Kind of yes and no. This is how it works. And you just add another one for each individual. What's it called? For each individual bit that a register is, you would just add another one in. Yeah, for sure. No problem. Yeah, that could help. And like I said, I'm gonna post the other channels for or discords for next quarter for 178 and 132, and I'll make another text channel for that. And then if you guys join them, join them. No, yeah, no problem. I'm glad it helped, Bailey. Also gonna make the Piazza post today about grades if people are interested in doing that. So for sure. Um, Travis, honestly, I have no idea. She told us that it was like part of what we went over. If you know how to do a D latch though, someone was saying like it's super, super simple. Um, yeah, Kate, I don't even know how to say your name. I'm so tired. It's posted. Also, I posted a study guide this one that I wrote up that has everything that she talked about and nothing else. So I didn't include some of the stuff that she may have missed, but so if you just use either one of those, you should be good. She technically finished going through it, yeah, Chris. She just like she skipped over some stuff. I don't remember what. I'd have to go look, but I know she skipped over like one or two small things. But she finished her slides, I believe. Cool. But yeah, thank you everyone for being in the Discord channel. It was
Yeah, good
lit.
job, man.
Yeah, thanks to you. Okay. Yeah, no, but seriously, thank everyone for the input in terms of like helping out. I feel like this was super helpful for labs, for the quizzes, for everything. So yeah. Um, I don't know what that is, but we're opening it. This is not from this class. Don't be stressing me out. Oh, is that 132? I'm into it. Is this last quarter's 132? This quarter's 132? 132 final hasn't happened yet. What do you mean? Oh, it's the final review she gave you. Okay, for sure. Yeah, it's from 2015. Yeah, it is. Okay. Um, Thank you, Paprika, for recording everything. Um, yeah, I feel like it'll be like another hour or two, and then it might be up.